In the previous lecture we have introduced logical equivalence. In this lecture we will discuss another notion to compare abstract propositions, logical consequence. At the end of the previous lecture we have considered the following two abstract propositions, A and B or C, and A and B or C, and we have already stated that these abstract propositions are not equivalent. And I've actually asked you to, in preparation for this lecture, write out the truth tables for these abstract propositions to confirm that they are not equivalent. And then probably you have produced something like this, perhaps with extra columns for B or C and for A and B. And then we can observe from this truth table that these abstract propositions are not equivalent because in the second and the fourth row the right-hand side abstract proposition evaluates to 1, whereas the left-hand side abstract proposition evaluates to 0. These two ones on the right are not carried over to the left. You may also have observed that actually looking at the left-hand side abstract proposition, whenever that abstract proposition evaluates to 1, also the right-hand side abstract proposition evaluates to 1. So the ones from the left-hand side abstract proposition are carried over to the right-hand side abstract proposition. In fact, this means that you can think of the truth of the left-hand side abstract proposition as a sufficient condition for the truth of the right-hand side abstract proposition. This gives rise to a notion of logical consequence. Q is a logical consequence of P if for every assignment of truth values to the proposition variables in P and Q, it holds that if P evaluates to true, then Q evaluates to true. We introduce specific notation for that. We write P is stronger than Q with an equivalent sign and a bar on the left if Q is a logical consequence of P. And we may also write Q is weaker than P for Q is a logical consequence of P. Let's see a few examples. So first of all, let's consider the example of these abstract propositions A and not B implies B and A implies B. And we have already discovered in the previous lecture that these abstract propositions are equivalent. Indeed, the ones are carried over from left to right. So whenever the left-hand side abstract proposition is true, then so is the right-hand side. And therefore, the left-hand side abstract proposition is stronger than the right-hand side abstract proposition. But we also have that the ones are carried over from right to left. Whenever A implies B is true, then so is A and not B implies B. And therefore, we can conclude that A and not B implies B is also weaker than A implies B. So here we see that, the logical consequence goes in both directions. Let's now consider another example. Let's consider the abstract propositions not A and A implies B. Well, first of all, you may notice that the ones in the column for A, not A, are carried over to the right, showing that not A is stronger than A implies B. But you may also observe that the A implies B is true also in the fourth row when not A is not true. And this actually shows, because this one is not carried over from right to left, that not A is not weaker than A implies B. So whereas in the previous example we had the logical consequence in both directions, here we only have logical consequence in one direction, from left to right, from not A. A implies B is a logical consequence of not A. Logical consequence gives us a way to compare abstract propositions. If P is stronger than Q or P is weaker than Q, then we'll say that P and Q are comparable. And otherwise, so if neither of these relationships holds between P and Q, we say that P and Q are incomparable. In the examples we have seen so far, the abstract propositions considered were always comparable. Let's now consider an example of two abstract propositions that are incomparable. Look at the truth tables for A implies B and A or B. You may notice that there's a 1 in the first row for the abstract proposition A implies B, which is not carried over to the right, which is not carried over to A or B. And this shows that A implies B is not stronger than A or B. On the other hand, there's a 1 in the third row for the abstract proposition A or B that is not carried over from right to left, showing that A implies B is not weaker than A or B. Since A implies B is not stronger nor weaker than A or B, we conclude that they are incomparable. Logical consequence gives us a way to also express general properties of connectives. Let's first consider conjunction. For all abstract propositions P and Q, it holds that the conjunction P and Q is stronger than P. So P is always a logical consequence of the conjunction P and Q. To prove this, this general logical consequence, this general weakening, you could say, we give a truth table. Here you see the truth table for P and Q, and the column for P is repeated, and we, as you may notice, we list all possible combinations of truth values assigned to P and Q, and then we see that the single one in the column for P and Q is carried over from left to right to the column for P, showing that indeed P and Q is stronger than P. We also have that P and Q is stronger than Q. So also the right-hand side conjunct is a logical consequence of the conjunction P and Q. Now let's consider disjunction. So a disjunction is always a logical consequence of both its disjuncts. So P is stronger than P or Q on the one hand, and on the other hand Q is stronger than P or Q. Finally, let's express some logical consequences using true and false. So false is always stronger than any other abstract proposition P. So we could say that false is actually the strongest abstract proposition. On the other hand, true always is a logical consequence of any other abstract proposition P. So P is always stronger than true, or stated differently, true is the weakest abstract proposition of all. This concludes our discussion of logical consequence.